Hello everyone, my name is Wojciech and I'm a network engineer for Mirantis. In this video, I will clarify what microsegmentation is and how it can be implemented with Tungsten Fabric Application Policy. Let's take a closer look at microsegmentation. Traditionally, organizations protect their network perimeter by screening north-south traffic on the network edge. But perimeter-focused defenses have no visibility into east-west traffic, which can be used by attackers to move laterally across workloads. Here, microsegmentation comes to help. Microsegmentation refers to an approach to security that involves dividing a network into security zones and applying security controls to each security zone based on its requirements. The security zones isolate workloads, securing them individually with custom workload-specific policies. Mirantis openstack for Kubernetes with Tungsten Fabric networking backend provides tag-based application security policy feature, which can be used to protect the application itself by screening clients' north-south traffic and to secure east-west communication between application tiers, deployment environments of the application instance, or the geographical location where the application is deployed. Let me briefly characterize the application policy construct. There are three different firewall features supported by Tungsten Fabric, which are security group, network policy, and the application policy. The major difference between them is that security groups and network policies apply to VM ports and virtual networks respectively, whereas application policy applies to applications. Application policy segregates the east-west traffic based on dimensions, such as application, tier, deployment, or site. Even though it's still possible to leverage virtual network names or addresses to identify endpoints, one builds IP-less firewall policies using tags. It prevents from proliferation of IP-based firewall rules, which are difficult to manage and understand when troubleshooting. What are tags? Tags are key value pairs associated with different entities in the deployment. They are basically used to identify objects and workloads. Application policy can be ported between different application deployments. For instance, if a development environment is deployed first, and staging and production environments are added later, no environment-specific rule updates are required for existing firewall policy. The only thing which needs to be done is assignment of appropriate tags to the ports of newly added VMs. It's not necessary to create brand new virtual networks and subnets every time a new application deployment is added. The VMs of different application instances, such as development and staging, may share the same virtual network segments, but the cross-deployment traffic won't flow between application layers if deployment match condition is used as a part of a firewall rule. Tags can be generally assigned to different objects, but in our lab exercise, we'll only tag VM ports using global tags. It's worth mentioning that both tags and application policies can be global or project-specific. As opposed to Tungsten Fabric Network Policy, Tungsten Fabric Application Policy does not interconnect virtual networks. If the workloads contained in a firewall rule belong to different virtual networks, a logical router or network policy must be added to enable connectivity between endpoints. No deny all rule has to be added at the end of the firewall policy, as is contained in each firewall policy implicitly. Last but not least, application policy cannot be configured from openstack, as it's Tungsten Fabric proprietary feature, not supported by Neutron API. That's why all application policy components in the lab will be set up through the Tungsten Fabric Web UI. A few words about tags, which are a key building component of firewall rules forming an application policy. As already stated, tags are key value pairs which can be assigned to different objects such as projects, networks, vRouters, or VM interfaces. In our lab exercise, we'll tag VM ports by using the first three tag types shown in the table. The application tag will be leveraged to identify all the application components. Tier tag will group instances of the same type within the application, whereas the deployment tag will facilitate isolation of the application deployments such as development and staging. Let's go to the demo part. In this exercise, I will show you how to secure communication between different layers of typical three-tier application, how to isolate two different application deployments sharing the same network segments, and how to protect the application itself by securing its web server exposed to clients. Now let me present the network setup used in the lab. We will make use of 7 pre-configured Cirrus VMs, 3 for the development application deployment, 3 for the staging environment, and 1 for the client. There are 3 openstack networks: access, frontend, and backend, shared by development and staging app deployments. For Cirrus VMs to work with 2 network interfaces, a customization script shown in the slide has been injected. In this slide, I will visualize all the components of the lab along with relevant traffic flows. As shown in the diagram, our 3-tier Mirantis app comprises development and staging deployments. The client VM can access web server of development and staging environment with ICMP, HTTP, and HTTPS only. Since our Mirantis app is dummy, we'll use some dummy ports opened by default on Cirrus VMs forming respective application tiers. The web server will communicate with the application server using SSH, while the application server will use ICMP to access the database server. Keep in mind that the cross-deployment traffic between application layers is not allowed. For instance, the web server from staging environment cannot SSH the application server in development environment, or the application server in development environment cannot ping the database server in staging. Even though there are quite many endpoints and traffic flows in the diagram, we'll configure just a couple of IP-less rules in the firewall policy, which will protect the application itself and segregate east-west network traffic between the application tiers and the deployments. The OpenStack VMs by default start with port security enabled and default security group assigned. In our exercise, we'll disable port security for all ports and remove security groups to make sure that all the interactions are controlled by Tungsten Fabric Application Policy. Before we get started with application policy configuration in the lab, let me highlight the configuration steps to be performed. Keep in mind that all configuration actions will be conducted from the Tungsten Fabric Web UI, presuming that all the VMs with their ports in respective OpenStack networks already exist. The first step is to configure deployment, tier, and application tags, which are basically key value pairs. Next, the tags need to be assigned to VM ports, which is probably the most time-consuming task. Another step is configuration of service groups. A service group is nothing more than a collection of protocols and ports for a specific network service. Once service groups have been created, we can start with firewall policies, which are a collection of firewall rules referencing the service groups and the previously configured tags. Finally, we dive into setting up application policy set, which associates recently configured firewall policies and the respective application tag. Keep in mind that the application policy won't be active until the application tag is set. Let's move on to our lab environment. Let's begin with adding tags. The application tag to be used to identify components of the Mirantis app. The deployment tag to be leveraged to isolate different app deployments, development and staging. And finally, the tire tag, which will be used to group instances of the same type. We got web server, we got the application server, and the DB server. Once complete, we can get started with assigning tags to VM ports. Let's move on to the ports section of networking. All VM ports will be assigned application, deployment, and tire tags except the client VM, which is not a part of the application. We'll make use of our lab diagram to identify respective VM ports in the port list and to select appropriate tag values. After tags have been assigned, we can proceed with service groups, which will be referenced later on in the firewall rules. We go to Security, Global Policies, Service Groups, to configure services running within our application. For our dummy Mirantis app, we'll define web, SSH, and ICMP services only, as shown in the diagram. Once complete, we can move on to the firewall policy configuration. We go to Firewall Policies to proceed with configuration of two different IP-less firewall policies, one for client access and the other one for communication between application layers. The client access policy will comprise two permit rules, allowing web and ICMP traffic between the virtual network the client VM lives in and the web server tier. The internal access policy will contain another two permit rules in its rule set, one for the SSH communication between the web server tier and the application tier, second for ICMP traffic between application and database tiers. In addition to endpoints, services, and direction, the firewall rules of the internal access policy will be configured with deployment tag acting as a match tag. This prevents the traffic permitted by policy rules from flowing between different tiers of development and staging app environments. Please note that there won't be any deny rules in the firewall policy rule sets because they are not required. As per the Tungsten Fabric security principle, everything which is not explicitly allowed is denied. Let's move on. Keep in mind that the firewall policies we've just configured don't need to be modified every time a new application deployment is added. The only thing to do is to tag network ports of recently added VMs. Also note that the multidimensional traffic segregation is achieved with a couple of basic tag-based firewall rules instead of an extended rule set comprising IP addresses of endpoints. Now the final step, which is a configuration of the application policy set. In this step, we'll associate the firewall policies we've created with the application. Be aware that the application policy for an application won't be active until an appropriate application tag is selected. If for any reason application policy for an application needs to be disabled, it suffices to strip the application tag from application policy configuration instead of removing the application policy itself. To make sure that the application policy works, we'll execute a number of connectivity tests from the client VM towards the web server and between different application tiers, including cross-deployment connection attempts. Furthermore, we'll inspect actions taken by the firewall policy for both allowed and denied traffic on the compute nodes by using Tungsten Fabric flow command. Finally, we'll take a look at the security dashboard and the traffic groups for some stats and for visualization of interaction between different application components. Let's get started. In the first step, we'll check HTTPS connectivity between the client VM and the web server in both development and staging environments. The web server in the development environment has responded. The web server in staging environment has responded as well. Let's check the flow table. As we can see, for the traffic matching specific flows, the action is all over forward. Let's now take a look if the client VM can ping the web server in both development and staging environments. The flow table on the compute node where the client VM is living shows that the matched ICMP traffic is forwarded. Finally, let's figure it out what happens if we try to SSH the web server from the client VM. As we can see, the SSH traffic is dropped by the firewall policy. If we disassociate application tag from the application policy set, the application policy will not control the application traffic anymore and will be able to SSH the web server from the client VM. Now let's check if the application policy secures the east-west traffic between different application tiers within a deployment and between different deployments. As shown in the diagram, the web server tier and the application tier communicate using SSH. Let's try to SSH the development and staging application VMs from the development web server. The SSH communication within the development deployment works, but the cross-deployment SSH traffic is dropped. It can be observed by executing flow-l command. Even though all the application and the web server VMs share the same network segment, SSH traffic won't flow between the development web server and the staging application server because the deployment tag has been used as a match tag inside the firewall policy. As soon as the application policy is disabled, the cross-deployment SSH traffic starts to flow. In the last test, we will verify if the application and the database tiers can talk with each other using ping as shown in the diagram. We'll also prove that ICMP works only within a deployment and no other traffic than ICMP is permitted between tiers. We go to the development application server and ping the development DB server and staging DB server accordingly. The development DB server responds. The staging DB server does not respond because of firewall policy which blocks cross-deployment traffic. SSH is not allowed at all between application and DB tiers within the deployment and between deployments because of the implicit any-all rule. All the interactions between different application components can be easily visualized using the traffic group chart. The outer circle represents the deployment, whereas the inner circle shows different application tiers. The blue curves symbolize inter-tier traffic, which is allowed by the application policy, while the orange curves depict the traffic denied implicitly. An example of permit traffic is the SSH interaction between the web server and the app server in both staging and development environments. The highlighted orange curve shows the denied attempt of cross-deployment ICMP communication between the application and the database tiers. Last but not least, in security dashboard section, among other things, we can observe the top applications, top tiers, top sites, top deployments, top virtual networks, and top virtual machine interfaces with deny in terms of send and receive traffic. I hope that the video was informative for you, and thank you for watching.